Welcome to True Projects. In this video, we are going to explain about the project that is weighted feature selection for machine learning based accurate intrusion detection in communication networks. Before getting into the execution, first let us understand what is the project about. An intrusion detection system, that is IDS, is basically a security system that is designed to monitor and also protect communication networks from cyber attacks and unauthorized access. Think of it like a security guard for the internet, keeping an eye on what's happening in the network to spot any malicious activity. Now, with all the new technologies that have been emerged, so with all the new technologies like big data, Internet of Things, that is IoT, edge computing, cloud computing, and wireless sensor networks, the amount of data being generated is huge and getting more complex by the day. For example, consider IoT devices like smart home appliances or wearables that are constantly collecting and sending the data. This massive amount of information can easily overwhelm traditional IDS system. And what is even more challenging is that a lot of this data includes unnecessary or redundant features that don't really help in detecting intrusions. It is like having a huge pile of information with a lot of noise mixed in it, making it difficult to pinpoint what is actually important. Imagine you're looking for a needle in a haystack, but there are a lot of other things mixed in that aren't even relevant to what you are trying to find. So this makes the building an efficient ideas more complicated. To get better at detecting threats, the system needs to focus on the really important data and not getting bogged down by all the irrelevant details. So, the main challenge with the intrusion detection system today is efficiently managing the complex data, large and complex data sets. As technology like IoT and big data generate vast amounts of data, ideas need to shift through the information to accurately detect intrusions. However, many existing ideas face difficulties. So, we do have some existing methods, we do have some traditional methods, but there are limitations to that. That limitations are they are poor at feature selection, feature extraction, meaning they have sometimes they process irrelevant data. They sometimes process the irrelevant data that doesn't help in identifying actual threats. So this leads to issues like false positives, slow performance, and also high resource usage. To improve the idea's performance, it is crucial to focus on selecting the most relevant features while eliminating the non-contributing ones. So this not only enhances the detection accuracy but also reduces the computational time and resources, making the system more efficient overall. Optimizing feature selection is key to improving ideas in today's data heavy environment. To overcome all these issues in this project is all about making intrusion detection system more accurate and also efficient. It tackles one of the major challenges of the ideas, which is selecting the right features. So here we will be selecting the important features, that is the right features of the data that will help to identify the threats. Often, ideas ends up processing too much irrelevant information, which slows them down and reduces their effectiveness. So, this project focuses on picking out the most important features that have the highest impact on detecting intrusions, so we can ignore the unnecessary data and boost the system performance. To do this, we use machine learning technique, that is specifically statistical technique called chi-square statistical method. So this will help us to identify the best features based on how much they contribute to the classification task. This allows the system to focus only on the most relevant data, making the detection process faster and more accurate. So in this project, we are using CIC IDS 2017 dataset to train all the models. So from this dataset, we will be selecting the important features and we will be training the algorithms. So we tested the system using the CIC IDS 2017 dataset, and the results show that it has significantly improves the detection accuracy while cutting down on the computation time. We have compared our method with other popular machine learning algorithms that are called linear SVM, that is support vector machine, naive Bayes decision tree, random forest, etc. So this comparison showed that our system is better at reducing irrelevant features and improving the classification accuracy. Essentially, by addressing common issues like high false positives and heavy computation in traditional ideas, the system provides a balanced solution that improves both detection accuracy and also computational efficiency, making ideas more effective in protecting communication networks. So this is all about the proposed system. Moving on to the extension part. To further improve the accuracy, in this project, we are incorporating an ensemble-based method, that is voting classifier. Think of it like a team of experts. Each individual makes its own prediction, and then voting classifier combines those predictions to make the final decision. This way, the system benefits from the strengths of different classifiers, which helps to reduce the errors and improve the overall accuracy. It's like having multiple opinions to make sure you're making the right choice, which in turn boosts the idea's performance in detecting intrusions. On top of that, we have also built front end using Flask framework. So this part of the system allows users to interact with it more easily by providing a user-friendly interface for testing the ideas. The front end also includes user authentication, so users can securely log in and test the system without any security concerns. This extension helps making the system more practical and also accessible, ensuring it is ready to use where usability and security are the key. Moving on to implementation of the project. To implement this project, we have followed the steps in the flow of work. Let's understand them. So first step is to import all the necessary libraries and packages. These include Pandas, scikit-learn, matplotlib, Flask for data manipulation, machine learning, visualization, and web development. Coming to the next step, we explored the CIC ideas 2017 dataset by categorizing into different classes. Like we we detect binary outcomes like normal versus attack. We identify multiple classes, that is multiple attack types involving, and the next one is all classes. So this involves all the types of attacks, normal data in the analysis and the normal data in the analysis. The next step is data processing. Here we clean the data. First, what we do is we clean the data by removing any repeated rows to ensure the accuracy. Then we remove the unnecessary columns or rows with missing values are, I mean here, unnecessary columns or rows with the missing values are dropped to make the data cleaner. And visualizations, so this step scales the features so that each feature contributes equally to the analysis. Coming to data visualization, here visualizations like graphs and charts are created to understand this data structure and patterns, helping in identifying trends and outliers. After that, coming to the next step is label encode. Here, categorical data such as attack types is converted into numerical labels for better processing by the machine learning models, because they will be not able to take the categorical data. They will be only taking as input, that is numeric data. And using chi-square feature selection, that is chi-square test, we select the most relevant features that contribute to the prediction, and we eliminate irrelevant or redundant features. Then the data is split into training and testing sets. One part is used to train the model, that is, training set is used to train the model, and the other is kept aside to validate the model performance. So we use test set to validate the performance. Coming to building the model, here machine learning models are initialized and then they are trained on the training data set to learn patterns and improve the predictions. And they are evaluated using accuracy, precision, recall, and FN score, and they are compared through the graphs. Coming to the part of front end, the Flask framework is used to create a web interface where users can interact with the system, and user registration and login are handled using SQLite database for security. And users in the front end, they will be able to provide the feature values, that is network data or attack details, through the front end interface. And that input data is processed in the same way as the training data by normalizing and encoding, so it is ready for prediction. It is done in the backend. Coming to the next step, the pre-processed user input is passed to the trained machine learning model, which makes the prediction based on learned patterns. And the result of the prediction is displayed in the front end, whether there is attack or not. If there is attack, it will detect which type of attack it is. Moving on to the algorithms used, these are the algorithms used to train the model so that we can detect the attacks. So we have used random forest, decision tree, linear support vector classifier, naive bayes, and the extension model voting classifier. Coming to the requirements, to implement this project, we need basic requirements, that are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let us execute. To execute, we need to open the code folder of the project which contains source code files. So let us open the code folder. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in the project? So coming to CIC ideas 2017 folder, in this we have the dataset that is used in the project. And that dataset is used to train all the algorithms so that we will be able to detect all the types of attacks. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Coming to app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have two model files which contain the algorithm information, and this will be loaded into the project code during runtime of the application. And here we do have one notebook file, that is the IPYNB file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows us to it allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have two sample files in which we have test cases. So in this project, we are going to detect the attacks in the binary class and also multi-class. Binary means we will be just detecting whether there is attack or not. And coming to the multi-class, here we will be detecting the attacks. And if we give the input, it will be detect. If first it will detect whether attack is there or not. If the attack is there, it will detect which type of attack it is. So this is the difference between binary and multi. So let's open the sample file of binary. So these are the test cases that we will be using in the front end. So here, if you observe, there are only two classes, that is 0 and 1. I told you binary, right? So here we do have only 0 and 1. Let's close this. Let's open the sample multi file. And here, if we apply filter, you can see total we have 7 different types of attacks that we are going to detect in this multi-class detection. Let's close this. And here we have signup.db file. This file is a database file which is used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer to execute. So I'm copying the path. Now open the Anaconda prompt. So here give the command cd followed by the space, paste the copied path. Now click on enter. Here, if you observe, by giving this command, current directory is changed to the code folders path. Now we have to compile the app.py file. So give the command python space app.py. Now click on enter. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. Give your username and the password to sign in. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So in this project, we are going to do both the binary classification and also multi-class classification. Let's do first binary classification. Click on binary. And here you can see all the parameters, right? We need to give them as input to detect the attacks. Let's understand all of these. What are they? So first we have is BWD packet length max. It is the maximum size of packets sent from the server, that is backward direction during a session. This can indicate the nature of traffic or the data transfer size. Next we have is backward packet length mean. It is the average size of packets sent in backward direction, useful for understanding the general packet size distribution. Then we have is flow IET max. It is the maximum inter arrival time, that is IET between packets in a flow, which can signal delays or bursty traffic patterns. Then we have is forward IET max. It is the maximum time interval between packets sent from the client forward direction, potentially highlighting irregular traffic. Coming to packet length, it is the maximum size of packets in the entire session, providing insights into the largest chunk transferred. Then we have is packet length STD, that is standard deviation of packet sizes in the session, showing variability in data transmission size. Coming to average backward segment size, it is the average segment size of packets sent in the backward direction, often related to server response patterns. Then we have as the IDLE mean, that is the average time the connection remains idle during a session, reflecting the inactivity or gaps in the communication. Then we have as the idle max. It is the maximum idle time in the session, which could suggest periods of number of data exchanges. Coming to idle min, it is the minimum ideal time during the session, useful for identifying the shortest gaps between data transmissions. So this is all about the parameters. Let us enter them. For that, let's open the sample file. Open the sample binary file. Let's open this. So let's try with the first case. That is the first test case. First, we are supposed to enter the backward packet length max. Then we are supposed to Then next we are supposed to enter backward packet length mean. Next is the flow IAT. Copy that. Flow IAT max. Flow IAT max. Packet length. Next we are supposed to enter is the packet length standard deviation. Average backward segment size. Idle mean is 0. Idle max is 0. Idle min is 0. And then we have entered all the parameters. Now click on predict. So here, based on the given input, here we got the prediction as no attack is detected. It is benign. That means there is no attack. Let's try with the class 2. Sorry, second test case. Click on prediction. Click on binary as we're doing binary prediction. So backward packet length is 329. We have backward packet length mean is also 329. The next we are supposed to enter is flow IET max, that is 60940, and flow IT max, the next we have is 0. Packet length max is 329. Next we have is the packet length standard deviation. Average between segment size is 329. And rest all we have is 0. Idle mean, idle max, idle min are 0. So here we got the prediction that attack is detected. It may be any of the attacks. So it may be DDoS attack or any other attack. So this is how we do the binary classification. Now let's do the multi-class classification. Click on multi-class. So here we have other set of parameters that are need to be given as inputs. Let us understand what are these also. So first we have is the flow duration. So here we have flow duration. It is the total time a session or a connection last measured from the first to the last packet. It helps in analyzing sessions activity duration. Then we have backward packet length. Mean we heard it about it in the binary classification. We also heard about flow IAT max in previous. Then we have forward IAT total. That is the total time of all intervals between consecutive packets sent in the forward direction, providing insights into the overall data transmission speed from the client. Then we have forward IAT standard deviation. It is the standard deviation of the inter-arrival times of forward packets, reflecting variations in the client side data transmission. Coming to forward IAT max, it is the longest interval between packets sent forward, potentially highlighting significant pauses or irregularities. Coming to fin flag count, it is the total number of fin flags in the flow, which indicates the number of attempts to terminate a connection. Then we have is idle mean, idle max, and idle min. We heard about this in the binary classification itself, right? So let's enter this parameters. For that, open sample multi. So let us enter the parameters. Copy the flow duration, paste it. Let's try with the first case. Before that, let's see how many classes we do have here. Let's apply filter. So here we have total 7 types of attacks. Let's try with the zero class first. Let's try with the first case of first sample of zero class. So flow duration is 165. Next we have is backward packet length mean, that is 59. Flow IET max is 114. 3 is the forward IET total. 0 is the standard deviation. Max is 3. Fin flag count is 0. Idle mean is 0. Idle max is 0. And also idle min is 0. Now click on predict. So this input will be pre-processed at the backend, and then train model will be giving us a prediction. So here we got the prediction that no attack is detected. It is benign. That means there is no attack here. Here zero class refers to the no attack. Now let's check with the class 1. Click on 1. So here let's try with this case. Click on multi-class. Select the flow duration, paste it here. Backward packet length, flow IAT max, flow IAT total, flow IAT standard deviation, flow IAT max, forward IAT max it is. Next, all the values are 0. Now click on predict. So here we got the prediction. There is attack, and that attack type is bot attack. So here you can observe that attack is detected, and it is also detecting which type of attack it is. So here bot attack has been detected. Now let's check with the other class. That is the other type of attack. For that, let's check with the class 2. Let's try with the first one. Copy the flow duration, paste it. Backward packet length is 0. Next, flow IAT max, flow IAT total, forward IAT total it is, forward IAT standard deviation, forward IAT max. Next, all values are 0. Now click on predict. So here we got the prediction that attack is detected, and the attack is brute force attack. So here brute force attack has been detected. Now let's try with the one more class. So let's try with this one. So the first we have is the flow duration. Backward packet length is 0. Flow IET max is 0. Sorry, 10,30,000. And then forward IET, forward IET standard deviation, forward IET max, fin flag is 0. And the rest all values are 1 crore 30 lakhs. They are 1 crore 30 lakhs. So paste all the values like that. Now click on predict. So here we have given the inputs, and here we got the prediction as attack is detected, and the attack type detected is DDoS attack. It is the DDoS attack. Let's try with the one more class. We have completed 0, 1, 2, and 3. Now let's try with the fourth class 4. So let's try with this one. Flow duration, backward packet length mean, flow IET max, forward IET total, forward IET standard deviation, forward IET max, and the rest all values are 0. Now click on predict. So here we got the prediction that attack is detected and the attack type is DDoS attack. Sorry, it is DOS attack. Initially we saw DDoS attack, right? So here we got the attack detected is DOS attack. Now let's try with the other class. So let's try with the class 5. So let's try with the first test case of class 5 where flow duration is 740. 2 is the backward packet length mean. 577 is the forward flow IET max. 740 is the forward IET total. Forward IET standard deviation is 0 and forward IET max is 740 and all the rest values are 0. Now click on predict. So here I have provided the input and we got the prediction that port scan attack is detected. Attack is there and that attack type is port scan attack. Now let's try with the last class, that is class 6. Let's check which type of attack it is. So we have to enter this flow duration, copy it. Backward packet length mean, flow IAT, forward IAT total, forward IAT standard deviation, forward IAT max, and the rest all values are 0. Now click on predict. So here we got the prediction that attack is detected and that attack is web attack. So here you saw multi-class classification, right? So here we have given the inputs. After giving the inputs, it will detect whether there is attack or not. So first it will tell there is attack or not. So if the attack is detected, it will show that attack is detected and which type of attack it is. It may be DDoS, DOS, probe, web attack, like that. Now let's check with the graphs. Click on graph. So here, first graph which we have is a correlation matrix graph. This shows the correlation between the variables. And here, this is the sample outcome graph. This is the sample outcome of all attacks that we have. And here on x-axis, we have all the attacks. On y-axis, we have the count of each class. And this is the accuracy comparison graph. These are the algorithms trained on the all types of attack data. And here on x-axis, we have accuracy score of each algorithm, and on y-axis, we have that particular algorithm name. And this is the precision score, recall score, and FN score. And here we have the multi-class here. These are the filtered attacks. So we have n number of attacks. We have, based on the similarity, we have grouped them. So these are the 6 different types of attacks. Here on x-axis, we have the attack names, and on y-axis, we have the count. So based on the similarity of the attack types, we have grouped them, and here we have given the distribution of each type, each attack count. So this is the accuracy comparison graph. This is the precision score. This is the recall score, and this is the FN score. And here all the algorithms are trained based on the grouped data, based on the attack group data. And here we have the binary class. So here we do have only 2 classes, that is there is attack and no attack. Benign refers to the no attack and attack is the there is attack. And here on x-axis we have class labels and on y-axis we have the count. And these are the algorithms that are trained on the binary class data. So these are the metrics which are used for evaluating and these are the comparison graphs of them. Now click on sign out. In this way, just by giving the inputs that are the network attack data, it will detect which type of attack it is. If there is attack, it will detect. If there is no, it will show that there is no attack in the multi-class. Coming to the binary, it will just detect whether there is attack or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.